Hello students, I hope you all are doing good and preparing well for DCET exam. So this is the next video in the trigonometry series. So this is I guess fourth video in the trigonometry series. So I would suggest you to uh, watch all my previous three videos so that you get a strong grip in this topic. Okay, so let's start today's session. So this is according to the diploma CTE syllabus. So in today's class we will be covering these two topics: trigonometric ratios of multiple angles and trigonometric formulae. So okay, so yeah, first we'll be starting with the transformation formulae. In the last class I have given a brief introduction on this topic, and next we'll be going to the important topic, that is the trigonometry ratios of multiple angles. Okay, first we'll be doing the sine 2x, cos 2x, tan 2x, then we'll be moving to sine 3x, cos 3x, and tan 3x. Okay, yeah, moving on. Next, okay, so the basic thing that we derived in the last class. So we know what is sine x plus y. It is sine x cos y plus cos x sin y. Sine x minus y is defined as sine x cos y minus cos x sin y. Okay, if I add these two, if I add 1 and 2 both on LHS and RHS, I get sine x plus y plus sine x minus y equal to 2 sine x cos y, right? This is the formula. If I replace x plus y with a and x minus y with b, okay, let me replace this. So here I can replace that, right? If I do sine of a plus sine of b equal to 2, what is x? Okay, if I add these two, if I add these 1 and 2, what do I get? I get 2x equal to a plus b, which is nothing but x equal to a plus b by 2. And if I subtract these two, if I subtract 1 minus 2, 1 minus 2, I get 2y equal to a minus b, which is nothing but y is equal to a minus b by 2, right? So here in this x and y, I can replace the x and y in this term. I'll get 2 sine a plus b by 2 cos a minus b by 2. That's it. So this is the formula. This is the that you need to remember. Okay, I hope the derivation was easy to understand. So what we did was we first did a substitution of x plus y and x minus y is equal to b, and we replaced these x plus y and x minus y. Then we found out x in terms of a plus b and a minus. Then we found out x and y in terms of a and b. That is how we got this formula. So this is a very important formula. You need to remember this. Okay. Similarly, in the last slide I did the addition. If I subtract 1 and 2, okay, I'll just show this. If I subtract 1 and 2, I'll get sine x plus y minus of sine of x minus y equal to 2 cos x cos y. And on similar substitution, x plus y is equal to a, x minus y is equal to b. On adding both, I'll get x equal to a plus b by 2 and y is equal to a minus b by 2. And making these substitutions here, I get a new formula, that is sine a minus sine b is equal to 2 cos a plus b by 2 cos of a minus b by 2. Okay, so same thing what we did previously. Okay, I hope it was clear. So this is also a very important formula. that you need to remember. Moving on, we have yeah, similarly this can be extended to cos. Here they have used a different variable. Using a different variable does not make any uh, change. Instead of a plus b, they have again taken x and y only. Okay, so this is the standard formula. Similarly, you can derive it for cos x plus cos y, cos x minus cos y. This is a homework for you guys, and the formula that you get is here. Okay, so I would suggest you to pause the video and make a note of all these formulae and memorize them. Okay, cos x plus cos y is equal to 2 cos x plus y by 2 cos x minus y by 2. Cos x minus cos y is equal to minus 2 sin x plus y by 2 sin x minus y by 2. Sin x plus sin y is equal to 2 sin x plus y by 2 cos x minus y by 2. Sin x minus sin y is equal to 2 cos x plus y by 2 sin x minus y by 2. Okay, moving on. Yeah, so this is a question we have got. So we can apply that formula right here. It is in the form of cos a plus cos b divided by sin a minus sin b. I know what is cos a. I'll just write it here. Cos a plus cos b can be written as 2 cos a plus b by 2 cos a minus b by 2. And similarly, sin a minus sin b is nothing but 2 cos a plus b by 2 sin a plus b a minus b by 2. I'll be applying these two. This I'll be applying in the numerator, this one in the denominator. So here I have cos 7x plus cos 5x, which will become 2 cos of 7x plus 5x by 2 cos of 7x minus 5x by 2. Okay, divided by, similarly in the denominator, 2 cos 7x plus 5x by 2 sine of 7x minus 5x by 2. So these are the same terms. I can cancel them. I am left with cos x sin x, and we know what is this. This is cot x. Okay, this is how you solve. So this was a direct formula substitution in the numerator and denominator. We applied the transformation formula and solved this. Okay, it was a simple question. Moving on. Okay, now coming to the multiple angles, trigonometric ratios of multiple angles. So this is an interesting thing. So sine 2x, what is sine 2x? We have studied what is sine of x plus y. What is it? It is sine x cos y plus cos x sin y. So in this, if I replace y with x, I'll replace y with x. What do I get? Sine of x plus x sin x cos x plus cos x sin x. So what is this? These two are same terms, so I can add them. Okay, so this is nothing but 2 sin x cos x. Okay, so this is how you do. So sin 2x is this thing, and this is the standard thing that you need to remember. And in terms of other trigonometric functions also, we can define sin 2x. Okay, in the denominator, we know there's a 1 setting here. I can replace that 1 with sine square x plus cos square x. Okay, now listen to me. I'll divide with cos square x on both numerator and denominator. 2 sin x cos x divided by cos square x sin square x plus cos square x divided by cos square x. So I'll get 2 tan x by 1 plus tan square x. This is the another formula that you need to remember. Okay, this is another like formula, and this is the This is the main formula, that is the formula. Okay, so this is how you can derive the formula, very important. Okay, moving on. Similarly, cos 2x, what we know, what is cos of x plus y? What is it? It is cos x cos y minus sin x sin y. I'll replace y with x. I'll get cos square x minus sin square y. So this is the standard formula for cos 2x. Okay. Now there are other we express it in terms of other trigonometric functions. Similarly, the same trick. In the denominator, I can write, sorry, this is sin square x. In the denominator, there is a 1 sitting there. I can replace it with cos square x plus sin square x, right? Now dividing with cos square x on the numerator and denominator, I'll get square x plus sin square x divided by cos square x. What do I get? 1 minus tan square x and 1 plus tan square x. Very important. This is the another trigonometric. This is the formula expressed in terms of tan. Okay. Now this can be again transformed. I'll tell you how. So we have got cos 2x equal to cos square x minus of sin square x. I can write cos square x as 1 minus sin square x, right? So I'll get a different formula now. I'll get 1 minus of 2 sin square x. Similarly, I can write one more formula, that is I can express sin square x in terms of cos square x. What do you say? It will be 1 minus of cos square x, which is nothing but 2 cos square x minus 1. So these are the three formulae for cos 2x. Okay, this is one, this one, and in terms of tan. All these you need to remember. There is no other thing. You need to remember this, but you should know how we got them. Okay, that is very interesting. Okay, yeah. Similarly, tan 2x. Tan 2x I don't want to do. I will give it as a homework to you guys. Figure it out. Okay, you can pause the video and solve it. Find what is tan 2x using tan x plus y, where there you will replace y with x and solve it. Okay, so quick recap. So cos 2x, we have got three formulae. The standard cos square x minus sin square x, 2 cos square x minus 1, and 1 minus 2 sin square x. Then in terms of tan, we have got 1 minus tan square x by 1 plus tan square x. For sin 2x, the standard is 2 sin x cos x. In terms of tan, it is 2 tan x divided by 1 plus tan square x. So I had asked you to try this, and 2x, you'll get 2 tan x 1 minus tan square x. Okay, that's it. Now we'll solve a question. Okay, so we have a question here. Okay, so I can use the transformation formula in the denominator and in the numerator for these two terms. Okay, I'll just rearrange the terms so that it is easy to understand. So I'll be applying the transformation formula here. So for these two, I'll be applying first sin 5x plus sin x is nothing but 2 sin 5x plus x by 2 cos of 5x minus x by 2 minus of 2 sin 3x. In the denominator, again I'll be applying the same formula, but here for cos, this is nothing but minus 2 sin x plus y by 2 sine of 5x minus x by 2. On simplifying this, what do I get? I get 2 sine 3x cos 3x minus of 2 sine 3x minus 2 sine 3x sine 2x. Okay, here I can take common 2 sine 3x, I can take common in the numerator. I'll get cos 3x minus 1, and in the denominator I have minus 2 sine 3x sine 2x. I can cancel these. I can write cos 3x minus 1. Okay, no, I am doing something wrong here. This is actually 2x, cos 2x. This is cos 2x minus 1. Here there is an interesting thing. Okay, I'll just rewrite this minus sign is there, so I'll use that minus sign. In the numerator I'll get 1 minus cos 2x, and in a denominator I'm left with sine 2x. Okay, okay, so listen to me carefully. We know what is cos 2x. In terms of sine square x, it is 1 minus 2 sine square x, right? We know this formula. If I send 2 sine square x in the LHS, I'll get 1 minus cos 2x, right? So I can replace my numerator with 2 sine square x divided by sine 2x. Sine 2x, we know what is it? It is nothing but 2 sine x cos x. Now on cancelling, I'm left with sine x by cos x, which is nothing but tan x. That is our answer. So this is how you prove. So we use the transformation formula. I'll just summarize this question for you guys. So here I applied the transformation formula for these two. In the denominator I applied for this. Then we took some things common, and then we applied the multiple angles formula, this formula here, and that is how we solved it. Okay. Okay, moving on. I hope this was clear to you guys. So it was slightly lengthy question, but with practice it will come. So I would suggest you to practice more, solve questions from NCERT textbook, class 11. You can get the textbook easily on internet. Okay, and solutions also you can find on internet. So this is again an interesting question. So sine square 6x minus sine square 4x, and we have to write it in terms of sine 2x sine 10x. So how to approach this kind of questions, that is more important. How what thought process you need to have. So in the RHS I have sine 2x sine 10x. How can I get this? Okay, we know something, cos of cos A minus cos B. What is this? Minus of 2 sine uh, A plus B by 2 sine A minus B by 2, right? So if I can express this LHS in terms of cos x, cos A and cos B, somehow I can reach here, right? Okay, because I know this can be expressed in this form. So if I'm able to express my LHS in terms of cos A minus cos B, I can uh, arrive at my RHS. So this is the thought process that you need to have. Okay, so okay, just now I showed you multiple angles, how we use multiple angles. What is cos 2x in terms of sin x? 1 minus 2 sine square x. So what is 2 sine square x? It's nothing but 1 minus cos 2x. And what is just sine square x? It is 1 minus cos 2x by 2. Right, I'll be using this formula. So I have, so for this thing, 1 minus of cos 12x by 2 minus of 1 minus cos 8x by 2. Okay, on simplifying this, I'll get minus 1 by 2 cos 12x minus cos 8x, right? So I got it in terms of cos A minus cos B, some cos A minus cos B. So I'll apply the transformation formula here. 2 sine of minus of 2 sine A plus B by 2 and sine of A minus B by 2. Okay. So 2 gets cancelled, minus gets cancelled. I am left with sine 10x and sine 2x. That is our RHS. So this is how you solve these kind of questions. So this should be the thought process. So all you will be doing is with using the formulae, and some you will be trying to express them, convert it from one form to another, and trying to arrive at our RHS. So this is how you approach the questions. I hope this question was clear. Moving, yeah, sine 3x. This is an important thing. I would suggest you to try this on your own, but sine 3x I'll do, cos 3x, tan 3x is a homework. So sine 3x, I can write it as sine 2x plus x. I can use my compound angles formula. This is nothing but sine 2x cos x plus cos 2x sin x. So sine 2x is nothing but 2 sin x cos x. Cos x is just cos x. Cos 2x, I'll write it in terms of sine square x, which is nothing but 1 minus 2 sine square x. Now, this is nothing but 2 sine x cos square x, and this is sine x minus 2 sine cube x. 2 sine x cos square x can be written as 1 minus sine square x plus sine x minus 2 sine cube x, right? 2 sin x minus 2 sine cube x plus sine x minus 2 sine cube x. So on just doing the simplification, I'll get 3 sine x minus 4 sine cube x. So this is the formula that you need to remember. Okay. So what I did first, I tried to reduce this from 2x to I came to x. So here you can see all the trigonometric functions are in terms of x. Then my next thing was I changed cos in terms of sine, and I simplified it. So this is our formula that you need to remember. Okay, moving on. Yeah, for cos 3x, similarly you can derive. That is a homework to you guys. Similar approach. So this is very important formula. 3 sin x minus 4 sin cube x. For cos 3x, it is 4 cos cube x minus 3 cos x. And for tan 3x, it is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So I would suggest you to derive this formula. It is very important. Okay, yeah, that was all for today's session. In the next video is going to be very important. So all the formula that is required, all the formulae that are required for trigonometry I have covered in my 4 videos. You can refer those videos, and all the things. So I'll suggest you to make a note of all those things and memorize. In my next video, I'll be solving a number of questions, all the previous year asked questions, how to approach them. So you'll get an idea to solve those questions. So that is going to be a very important session. So don't miss that. If this was helpful, please press the like button, and to stay updated with the new videos, you can join my Telegram group as well. Okay, thank you.